Hello friends, welcome to this demonstration in which I'm going to show you how to configure a 3-node OpenStack cluster with all important services including Glance, Keystone, Cinder, Swift, Object Storage, Neutron, Nova Compute Service, all these services. So the environment is I'm using my Oracle VirtualBox, and on this I have configured two host only adapters, 10.10.0.1. Second one is this 203.0.113.1, and the machines which I'm going to use are compute, controller, and storage. Let me show you the controller settings. The controller machine is using 6 GB of RAM, two processors, and as far as network is concerned, the first adapter is host only adapter, the first adapter. Second is internal, which will be used for my APIs inside my cloud, OpenStack cloud. Third is for provider network, external network from Oracle, from OpenStack cloud to internet. And the fourth one is internet connectivity, that is NAT to my instance. I'm talking about controller, compute, and storage machines so that they can download and install softwares. So this is the setup. Now to configure this, I need one extra storage. I want to add that right now. I'm creating the 4 GB space, 400. This 4 GB space, I'm actually configuring a 4 GB disk. I'm configuring which I will be using for Cinder block storage. So I configured one from controller. I'll be keeping this as storage, disk 1, controller 1 for my Cinder block storage. Similarly, for compute, I will be configuring 3 additional disks. So let me add those 3 disks here. One is for Cinder block storage. This will be those for Cinder block storage. In fact, C and B and C, that is second and third, will be for Swift object storage, and the third one will be for Cinder. That's going to be the plan. So second, now let me add one more. 4 GB, all 4 GB disk I'm adding. So this one and first and second, this will be used for Swift object storage, and this will be for Cinder. Similarly, I can add to the storage also. Storage is going to have only Swift object storage, nothing much. As far as configuration of this machine is concerned, storage, let me add the same 3 disk on this also. 3 disk, 4 GB. For this is for Swift object storage. Another one for Swift object storage, and that's it. I don't need another one here. I need C and B and C for Swift object storage. As far as configuration of this machine is 2.5 GB of RAM and one processor. For controller, for compute, what is the configuration? I'll show you that also. The system is 5.6 GB nearly the RAM, and two processors I have configured. Networking, same here. Host only first, internet internal network second, third is for provider network, and fourth is for NAT. This is the configuration. So let's start the machines. Compute, controller, and storage. So let the machine comes up. I'm going to pause my video. So I'm logged into my machines. You can see that controller, compute, and storage. Let me take you to controller machine. First of all, my etc host is configured. You see it is properly configured, where 10.10.1.11 is the IP address. This is using internal networking, the internal networking which I configured, which you have seen. Similarly, compute is 31 and the storage is 41. This file is same for all the machines. Also, what I have configured is key-based authentication for all the machines. If you see here .ssh, You will see the private and public key pair, and these keys are passed to all the machine, including to itself, including to controller. So I can use SSH, use to connect to controller directly, and I can use SSH to connect to compute. It's working fine, compute, and similarly it is working for this storage also. The same is true for all the machines, meaning from compute you can use SSH without password, that is key based authentication, to connect to compute, controller and storage. Same is applicable for storage machine. You can connect using SSH without password with key based authentication from storage to compute, controller and storage itself. Same thing I have done for root user as well. As root also I can connect. Just for demonstration, let me show you. If I switch to root user here as sudo su hyphen, so here I can connect to controller without password. This is configured here also for root as well. So similarly, if I try to connect SSH compute, it will work. So this is done for root user as well. So whether it is a root user or the user stack, the key based authentication is enabled to connect to all the machines. Why? My scripts will be using to connect to the machines to run commands on other machines setting on one machine. For that I configured this key based authentication. IP addresses, as you have seen, the IP addresses are, the first IP address is host based authentication. This IP address is where my OpenStack dashboard will be available, web console will be available. Not using this, this is storage machine, but the IP address of the controller machine. This is internal network. This is the IP address of the storage machine, which will be used for internal API connectivity. This will be the provider network, which will be used by OpenStack, and this is net-based IP address. All the machines have the same IP address settings. So here also you can see that IP space A on my controller. So this is 10.10.0.11, 10.10.1.11, and host only adapter. I mean this one is for OpenStack, and this is NAT adapter. Coming to the scripting, this all cleanup Ubuntu, because the scripts I have configured, I have modified, and I have been working on these scripts for quite long, starting when OpenStack Rocky was available. So the scripts are available for CentOS or Rocky operating system as well as Ubuntu operating system. So you can install, you can clean up, you can do installation. This is for cleanup, means removing all the packages. Currently, I'm using Ubuntu 22. So let's take a look at the all cleanup Ubuntu script. This is installing, removing all the packages, purging, deleting configuration files, deleting all the directories. This is a cleanup script which is removing everything, all configuration data. It will simply remove everything from the machine. If you want to clean up and you want to try multiple times, you can use these scripts. These scripts are available for that purpose. Similarly, the configuration file, config file, this file have various settings like OpenStack. What we'll be using in OpenStack, we'll be using this Cir OS image for testing the virtual machine. First network is my internal network. Second network is my management network, which is internal type IP address, and this is my provider network. So I will be using these environment variables for my scripting. So similarly, provider network CIDR block, gateway, start IP address and IP address. All these settings are configured in this, and the release I will be using Wallaby for configuration. Can you use the same? You just change this to Z, it will work Z. Similarly, you can use 2023 as well. Also, the credentials, all the credentials are configured at one place. If you look at this file have all the credentials, the database and user credentials, like this is database password, root db pass. This is a rabbit password. This is a admin user admin password, and all the stuff, admin pass, Cinder, glance. So all the API users and API password, and the database user for those APIs and the password for them. Everything is configured for that properly. So credentials after in addition to this OpenStack credentials and this, we also have a file admin openrc which will be used to authenticate the environment, set the environment for the user. This file is also configured. In addition to this file, there are a lot of other files, like there's a directory lib. Inside that there are functions. Functions for Ubuntu, functions for Fedora, functions for guest machines, for other machines also. So that's the functions file. Similarly, the image directory is for the images where I have downloaded the image. So let's get started. Script file is the directory where we'll do a maximum work. This is pre-download. If the image CirrOS image is not available, this is going to download that image. So let me show you pre-download. This will download the CirrOS image. You can see that the image, whatever image you configured, the URL and the image, this is going to download that and put that into the directory, that is image directory, img. You see here, img directory. This is going to put that. Since it is there already, so you will see that there's nothing output on this from the script. It says it's already available. You don't have to worry. So second is etc host file configure public network, private network we will do after our OpenStack is configured on this machine. So let's start with the Ubuntu configuration on Ubuntu operating system OpenStack. So there's a directory for that, Ubuntu, and here you see all the scripts available. I'll start with MySQL, then RabbitMQ, then Memcache. I'm going to do all this. So, but before that, I'm going to run this apt upgrade. What this script will do, vi apt upgrade. The script is going to install Python OpenStack client, going to upgrade that and going to perform dist upgrade and install some utilities like curl, tree and all that, and if up or if down. So I'm going to run this script. You may have to run it multiple times, so don't worry, you can run multiple times till the installation is successfully completed. Install RabbitMQ. That's a Rabbit message queue. It is going to install this package, RabbitMQ server, and is going to check the status. After that, is going to configure this user OpenStack with Rabbit password, and then it will allow set permissions to be used by OpenStack. So this is a quite straightforward script. It is using the path specified in the configuration directory, credentials specified in the configuration directory, and the functions available in the lib directory. That's different settings. The functions are being called execute log file, indicate current. These are the functions available in functions guest.sh. So let's run this. The RabbitMQ installation is complete. Let's take a look at this Memcache. We'll do the Memcache installation now. This is simply going to install this Memcache D and Memcache Python 3 Memcache. Also, it's going to configure it and enable the service. Of course, all the include files are same here also. Let's run this script. This is quite fast actually because there's only one package, two packages were required to be installed. So this will be fast. Done. Now we have already installed RabbitMQ, Memcache. We are good to start with our Keystone, the first service. The first file, the Keystone 1, this file has only the installation part of the packages. Look at this, is going to install Apache, is going to install Keystone Common and Keystone. So, and why this option? Because when I'm cleaning up my installations, it retain the configuration files. And if you notice in my all cleanup script, I'm removing those directories. So I need to reinstall those directories and files, default configuration files. That is the reason I'm using this option force config miss. So if there is a configuration file is missed, please install that. That's what I'm doing for Keystone and Keystone Common. Keystone Common. So let's run. So the installation of all the packages is complete, and as you notice, whatever files were missing, it is installing those configuration files as requested. Now let's look at this second file, which is doing the main configuration. So it is including the functions, OpenStack and credentials. Then it is creating the database on my database MySQL, configuring this, connecting to MySQL and verifying the details. After that is configuring keystone.conf file. And after that it's creating scripts, the users, roles and identities. Also configuring Apache details for Keystone authentication, and also to reduce memory footprint we are making some changes into this configuration file Apache site enable keystone.conf. We are replacing this here, substituting this default entry with this entry. This is reduce the memory footprint. Restarting Apache, enabling Apache, and then setting the environment variable for authentication, and finally verifying that, creating roles and users, issuing the token. What we have done so far is we have done RabbitMQ package, Memcache and package installation for Keystone. However, we have not installed MySQL. So let's run this script also. Install MySQL. This will install MySQL and configure MySQL. As you can see, MariaDB is successfully installed and started. It is active. This is done by script. Let me show you the script if you want. MySQL. This is doing the same process. Is first using the credentials path and all that, and then calling some functions from there, and it will configure and install MariaDB. So configuring MariaDB, installing MariaDB package, MySQL common and MariaDB server, Python 3 MySQL DB, setting up the root password, which was the database password, root DB pass, and then setting up the configuration settings for MySQL daemon for OpenStack, binding the IP address, max connections, DB file per table on data storage, the character set and collation. Then after that it's starting and enabling the MySQL. So MySQL is done. So now what we can do is we can configure, we can run this setup again, which I missed. So setup Keystone and number 2. This will install, configure the database. So you can see that database creation, waiting for the database to come up. Databases are created, users are created, and then setting the database connection into this file mysql.conf. This is the configuration file where the settings are done. Now waiting for Keystone to come up. Now creating the first project, demo project, demo user, user role, and the token. This is done successfully. So the Keystone is successfully configured on this machine. After Keystone is configured, what we can do is we can configure the glance image service. Let's do that with the glance API service, and that is image management service. In fact, we can configure etcd also, that is distributed key value store. So let me show you the script. Setup etcd. This is configuring the etcd distributed key value store. Install etcd and configure, make the changes into the configuration. So this is etcd, start and enable etcd. So let's install this etcd also, distributed database. Done. Now after etcd is done, we are going to do the installation of glance. Vi glance setup glance app1. This is the package. So it will install only the packages. So let's run this also. Please note that I had to run this script multiple times to install the packages because the repositories are not reachable in first attempt. I have to try it multiple times, 3-4 times I have to try every script. So let's look at the second, which will configure the service properly. So here it is including the credentials, calling the functions, and setting up the database, and then creating the user for glance API service, adding the roles, creating the service, creating the endpoints, and then configuring the service. This is the configuration changes into the API glance API configuration file, and these are the actions. We have a function, proper created function, init set sudo in the configuration file. This is the section name and these are the values. So all these will be configured and then starting it. Also, it is waiting for the glance to restart, so it is checking, verifying, and is importing a script. This is actually creating an image in the cloud, OpenStack cloud, and verifying that whether image is created successfully or not. Glance image list. Let's run this. So creating the database, you can see that creating the user, giving the admin role to the user, then making the configuration changes, populating the database, downloading the pre-downloaded image, configuring that image and displaying the image. So glance image API is successfully configured. So Keystone is done, glance is done. Let's move on to the Nova compute service, for which we have to first start with the placement. So placement is as usual. First script is for the softwares. So we will install the software first. And what all software? Placement common, placement API, and Python 3 pip, and OSC placement pip3. Let me call this script, and after that I will be back. With the successful execution of the installation, let's check the configuration settings for the same. So here, starting with once again the same file. Here it's sourcing the credentials file, waiting for the keystone to come up, and then creating the users. OpenStack user create, role add, service create, endpoint create, public, private, and internal endpoints, and then making changes into the Apache configuration file, symbolic links, making some changes here, and then configuring the placement.configuration file, the keystones action, and the database action, and restarting the Apache server. And after that, just displaying the available resources. Super. So let's execute this script. So this will configure the placement service for Nova, which is prerequisite for Nova. Perfect. So everything is perfectly done. Let's continue. Next is Nova. For Nova, we have these 4 scripts. The first script is as usual the software installation. Let's do that first. Installation of the software. So Nova common, Nova API, Nova conductor, Nova non-VPN, this no VNC proxy, and Nova scheduler. So let me install the software. After the package installation is complete, we'll see the service configuration script. So it is setting up the database. So this is creating the database, calling that function Nova API database, and then sourcing the configuration, and then waiting for keystone, and then creating the service related details in the keystone, where it is creating the user, creating the role, adding the role, creating the service, endpoint, public, internal, and admin, and then main Nova configuration file, where keystone section, then other section, default section, glance section, VNC section, all the sections are being configured here properly, and populating the database with these scripts, and finally verifying the things. So this is precisely the configuration for Nova. So let's finish this part. So the user being created, service created, endpoint created, configuration done, populating the database now. After this, we will move on to the next script, Nova script. Again, that will configure this Nova as a compute service. I want to keep my hypervisor for provisioning machines on both controller and compute. So let's move on to the third script. Third script of Nova is doing what? It is configuring Nova as a compute node. It is installing Nova compute and compute QEMU, and then making changes into this file, keystone authentication, default section, VNC section. But this is making it as a compute node now, because important point here is configuring, checking that whether you have KVM or this enabled or not. So if it is SVM or VMX, And based on that is configuring virtual machine type KVM or QEMU, because we need the hypervisor. So it is a simulator in my case. So it will configure QEMU in my case, and then verifying the details. So perfect. Let's run this also. Is complete, and now it is configuring the package. You can see the configuration is going on. Just before this, you can see after the package installation is complete, is verifying the services now. OpenStack compute service list. Yes, and see it is now verifying Nova compute is installed successfully. It is enabled and up, and everything is all. This is the output of this command, Nova status upgrade check. Everything is successfully configured. Now after that we have a fourth script. Let's see that fourth script also. What the script is doing, configuring the compute host as in the database. Let's see this script as well. This is placement, then Nova compute, configuring the compute host in the database and verifying and discovering compute host. Yeah, this is running some post installation scripts for the Nova and checking the status. Perfect. This is just a verification step. That is post installation steps. Generally we execute some steps. So restarting Nova compute service. After that we will move on to the Neutron. After the Nova is completed successfully, we'll configure the Neutron service, and after Neutron, on this controller node, we'll move on to the compute node configuration. You can see that everything is successfully working here. Perfect. So this is what we have done. So Nova is successfully completed. We'll move on to the Neutron. The process is same. The first script is the package installation. Take a look. Neutron common, Neutron server, Neutron plugin ML2, Linux Bridge agent, L3 agent, DHCP agent, and metadata agent. All these services will be needed. Let's install this script and do the configuration exactly in the same manner. Installation of package is complete. Let's see the second script, which will configure the Keystone services which we need. Let me go to line number 1, and here it's configuring the user, role, service, as usual, configuring the user roles and service, and then the endpoints. So quite straightforward, going to be quick, fast, very fast. We'll create the database, create a user, add the user to the admin role, create a service, endpoint. So once the service is done, let's check the next file, which is file number 3. So this script is actually configuring the Neutron service. So look at this main Neutron configuration file, etc neutron neutron.conf, and configuring all the sections here: default section, then Keystone authentication section, auth token section, then Nova section, then ML2 plugin section, configuring the ML2 plugin configuration. So then Linux Bridge agent configuration settings, then configuring all these files properly. And then let me finish this. It's going to be fast. Let's move on to the next file, number 4. This is configure the first option as per the documentation, where we have first option. So it is setting up the networking on the controller node. So metadata agent, then Nova configuration file settings, and verifying the services, starting the services, and this is again configuring, setting up the things, verifying the operations. So let's configure these. That is the fourth file. Populating the database now, Neutron database, restarting the services, verifying the operations now. The script is all completely automated and tested. So you can see metadata agent is configured, L3 agent is configured, Linux Bridge agent is configured, DHCP agent is configured, and all are up. Now the last here will be the fifth script, Neutron 5, that will be for configuring the private network. That the script is already executed. Yeah, one second. Yeah, this one is already self service. We configured this. This is done. Now we can configure the Horizon dashboard. So this is the script which will install and configure dashboard. So it's configuring the Horizon dashboard now, almost done. These are warnings, so deprecated. You can ignore them. I'll show you the file also, how it is doing. Done. And it is running. So let me show you the file. So it is configuring the path, including the functions. And here mainly it is configuring this file, OpenStack dashboard local settings.py. In this file, it is making the changes. That is OpenStack host name, allowed host, session engine, and location for Memcache configuration, memcachead.conf. And inside that memcachead, these are the changes available here. And finally, it is configuring the cache settings, OpenStack Keystone, this multi-domain support. All these settings is doing, and finally, it is making into changing into OpenStack dashboard configuration file under Apache also, and then using the settings and restarting Apache. So our dashboard is also complete. Now we can configure Cinder. Let me configure the Cinder, which is a block storage service. So Cinder controller, as usual, the first script is the software installation. You can see, oh, this time it is first script is configuring the service. Fine, creating the users, adding roles, service accounts, and endpoints, everything. So let's run this script. That's fine. This will create Keystone entries. And second, we'll install the software. Third, we'll configure it. And remember, we added one extra disk on this machine. So the disk number 2, SDB, will be used as Cinder Volume. So let's look at the file number 2, which will install the packages. So this is installing the package, Cinder Common, Cinder API, Cinder Scheduler, and then making changes into Keystone authentication file and other files, and synchronizing the database and verifying the details. Perfect. So let's run this script. Now we can start working on the compute node also parallelly. So same settings here. Let's go to the script file inside that Ubuntu, and here we will start with the Neutron on compute. In fact, first we should configure the Nova. Same script, process is same. Setup Nova compute 1. This will install the packages on this machine. And same we can do with the storage instance also. Scripts Ubuntu, and here inside this what we will do, we'll configure Swift. So this will install Swift packages. So let's run this script. Swift, this will install the packages for Swift, reading the package list. So after the packages are installed on this machine, we'll be back. So fantastic, this is done successfully. Nova compute is done on the compute machine. So let's configure the compute. Let me show you the same file. In fact, the same file is there on the controller also, compute 2. So this is the file, Nova compute service. On compute, main configuration file is etc nova.conf. So that's what we are doing on this machine. So installing the placement configuration, service user, and Nova, changing the permissions. This was a bug I identified and I fixed the permissions. So rest everything is verification the same way we have configured on that machine controller. So let's run this now. And what is the status on the software? On the storage node is going on fine, smooth. But here it is working. See, Nova Compute installed on controller and compute both nodes. Perfect. So you can see that endpoint successfully configured. Everything is verified. So here we have done set up Nova Compute machine. This is a second script we have executed successfully. Let's continue with the Neutron on this machine. So process is same. So I'll show you once what all software we are installing on this Neutron. The first is installing the software. It is Neutron Common and Bridge Agent. We don't need anything on this machine. Linux Bridge Agent and Neutron Common. So let's install this on the compute machine. And on the storage, in the meanwhile, installation of software is complete. Let's run the number 2. What is the script number 2 will be doing? I'll show you very interesting thing here. This script actually will do what? This will get the IP address, and it is using device the second disk and third disk on the storage machine to be configured for Swift object storage, making a file system and then making a directory for mount points and configuring the changes here. It's also pulling the files. It is also configuring rsync, and then it is pulling the file from Wallaby repository and putting them into etc Swift. If the directory does not exist, it is creating that. Then it is configuring account service. All these settings it's doing. So this is independent, so we can run this script to configure Swift on this machine. Let's continue on the compute machine. So Neutron 1 is successfully done. What is script number 2 is doing on the compute machine? See, it is doing configuring the Neutron. Installation of successful is done. Now it is configuring the Keystone authentication inside which file? Neutron.conf. So let's run this Neutron 2 after the package installation is complete on the compute. Done. And then Neutron number 3. What is Neutron 3 doing? Let's see that also. Neutron 3. This script is configuring the Linux Bridge agent importantly, and this is mapping the physical interface. The public interface is ENP0S9. It is mapping that, which is going to be provider network for me. And that's what we are configuring here. You will see the provider network, and which will be ENP0S9 in my case. And then enabling this net filter in etc sysconfig sysctl and putting that into this bridge net filter etc modules file also is going to make the changes. So let's run the script number 3. Done. And next is number 4 script. What this script is configuring? Nova, setting up the Nova for Neutron. That's it. So Linux Bridge agent is configuring the Nova configuration file etc Nova. Inside that is Neutron section. So we need to make changes into that section. So let's run this, and this will configure Neutron section inside the nova.conf file and restarting the compute service. On the storage section, what is happening? Swift number 2 is done. Let's see what is the script number 3 which will do here. The script number 3 is configuring this rsync, that is sync utility, which is synchronizing the files. Perfect. Let's run this also. So this is also done. Superb. Now here on the compute node, we have successfully executed Neutron 1, 2, 3, and now last file is fourth one is also executed. Swift, it is pending on this machine. Cinder is pending on this machine. You can check the history, what we have executed so far. So Nova compute, Neutron, this is what we have done so far on this machine. Let's configure the Swift and Cinder. So I'm configuring Swift on this machine, same process, exactly the same, it is a copy of the same file. So let me configure this. Setup Swift 1.sh, and in the meanwhile I'll go to my controller now. So what was the last file executed? Last script executed was Cinder. Cinder was executed last successfully. So Cinder was successfully done on this machine. Cinder controller 1, Cinder controller 2, and now let's move on to the Cinder controller 3. Let's configure Cinder controller number 3. What is this file first? Let's take a look. Number 3. This file will configure the Cinder block volume. So what it is doing? It is getting the IP address, configuring the first, as I said, this is configuring the Cinder device SDB. Second disk on my controller will be used as my block volume, and it is making changes into lvm.conf. It is filtering the device here. I'm replacing this with SCD stream editor, and I'm replacing this filter with this device name SDB so that it recognizes that, and it's verify after that. After that, it's installing Cinder Volume and configuring the Cinder Volume sections. And then Keystone auth token, default section, all these sections are configured. And then finally, it is verifying. It will create the volume, it will show you the volume being created, and it will terminate that volume. So let's run this. So what is the status on the compute right now? Wow, so Swift 1 is done successfully. I'm running Swift number 2 on the compute node. Same as DB and HGC. Remember, on disk number 2 and disk number 3 on compute and storage will be used as this Swift object storage. So now number 3 script will be rsync. This is also done. So Swift successfully executed. Now we are left with the Cinder on this machine. Let's configure. Verify once again. Swift, all the 3 scripts done. Neutron done. Nova done. So let's look at the Cinder. Set up Cinder 1, which will install the package lvm2 kimu, this tgt thin provisioning tool, Cinder common, and Cinder volume. So this will configure, install the Cinder packages on this machine. And which disk will be used? Point to be noted, on compute it will be the 4th disk, because disk number 2 and 3 are used by Swift on storage node and compute node. Disk number 4 will be used by Cinder, and that you will see in the next script. And see, done. So volume available, volume deleted. So, and the last script here is just verification of services, just testing the same thing, not doing anything else. It is just verifying, restarting the services, and using systemctl restart, Cinder scheduler, Cinder volume, and then it will create the volume and terminate it, just for testing the services. So here also it is going on the compute node. On the controller node, the volume is created, volume is terminated, volume is available now, it's going to terminate it now, and now it is gone. So Cinder volume is complete. Now we have to create a Swift on the controller node. So vi setup Swift controller 1, which will install the packages. Swift account, all these packages will be installed. These are missing, so these will install the packages on the controller node, and then it will pull the Wallaby file, main configuration file swift.conf into etc swift. If the directory does not exist, it will create it. If the directory already existed, it will simply pull the files. Quite straightforward. So let's run and install the packages. So this is just setting up the environment. So on the controller, on the compute, what was the last script? It is Cinder volume 1. So let's execute the second script, volume number Cinder volume 2. The second script is actually using the disk number 4 SDD. That's what precisely I told you. SDD will be configured as LVM for this Cinder volume service. And we are filtering the editor, I mean, we are setting up a filter in lvm.conf file. So this is configuring and then setting up the Keystone and other services. So let's run this now. This will be easy. Set up Cinder 2 and done. is super fast. So we are on the controller now, back, and this is also almost done. Yes. So this is a controller, Swift controller 1. Let's check the second file, controller 2. This file is creating Swift users and services, adding the role, adding this user to admin role and creating the endpoints, configuring the database, configuring the section. So this is doing main stuff for the object storage. Let's execute this script. Now our storage node is already done, finished. There's nothing pending on the storage node. On the Swift, the main script is going to be now the third script. This script is actually the main part of the Swift, because whatever configuration we have done on compute node and storage node will be used by the script number 3 now, and it will create this builders ring builder. Swift ring builder, account builder create, and this is using the IP addresses of my 31 and 41, that is compute node and storage node, and is building the ring. And this is where we require, this is building all the rings, like container builder, then it is object builder. So it is building all the rings, and then it is going to different machines. It is like going to controller, it's going to storage, going to compute node, changing the permissions, storage node going to change the permissions, is copying the files to other systems, like compute node is copying the files. So we are using SCP, and why the SCP will smoothly work, because we have configured key based authentication. So it will not ask me any password, it will configuring copying this file to the compute node, is copying this file to compute node, and similarly is copying the file to the storage node as well, and then finally changing the permissions there, and then verifying this settings. So this is the super fast script, and it will do everything for Swift object storage. Complete automation process for Swift object storage. So it is building the rings, you can see that. And now it is after the configuration is done, is going to synchronize the files, going to pass the files to the different machines. See here, SSH compute executing the files there, and then it will be using SCP also, you will see. And last script now will be the heat, that is basically orchestration service, where we can use YML format files. So this is perfectly done. So we are left with the heat. So let me configure heat also. Setup heat controller. This will install heat software, all the packages. The package installation is complete. Let's check the, in fact, let's take a look at this file, what all packages are installed as usual, which I've been sharing. Heat common, heat API, and CFN, heat engine, and then installing the heat dashboard, uh, copying all the packages to the file, and then compressing this. So this is mandatory. This is a very tricky situation. There was no documentation available on this. I have configured this successfully. Let's look at the second file, which is configured, which will create the service and will start and manage the services. So this is the same file. Now you have understood the flow is exactly same. So let me simply run the script now. So this will create the heat controller service. So it will create user, it will add the user to admin role, it will create a service, it will create the endpoint, it will configure the uh, main orchestration service heat, and then it will also configure the OpenStack dashboard with this. And now, by the time we finish this, we can start accessing the dashboard here. So 10.10. This is Horizon dashboard. And for your kind information, this entire video was brought to you by this website. This is my online learning portal, where you'll find a lot of courses on databases, clouds, Linux, OpenStack Cloud, and other courses also. including Amazon and SE Linux, relational databases and DevOps services, Rancher, Kubernetes. You will find all high-end technical courses. Minded, these courses are not for freshers. These are for professionals. These are advanced corporate training level courses which I've been delivering. So this is my user. I just log in. The dashboard is available now. But right now you will see that there is no network available. If you see on the network, there is nothing available. No router, floating IP address, nothing. Object storage, we can try now. Let's create a container. So I'm creating a hello world container, submit it. So this is my object store. Now I can upload the files, choose the file. Let me upload any course here, some file, upload, and super fast. Wow. Admin service, compute, hypervisors. You will see two hypervisor, compute and controller both. Compute host, you can see both of them are available. And as far as system is concerned, you can see the defaults. These are the system defaults, metadata information, system information, what all endpoints we have created through the scripts. You can see them here. The compute services, block storage services, network agents which are configured, where they are running, what is the status, everything. We need to test it now. We have some projects also. The users, it's self-explanatory. You can see all the users, the groups, the roles which are configured, and the application credentials if you want to configure anything here. There are some additional settings like here the time zone, then items per page. Then we can download the RC file, and then there are some these styles also available, some templates, material. This is another. So I love the Ubuntu template. This is wonderful template for me. Canonical Ubuntu. So let's create a router and instances and verify the services. And see here, Heat is successfully completed. So let's go back to one directory and here we'll configure private and public networks. First, I'll configure public network. I'll show you config public network. The script will configure the public network. So resourcing the admin file, then checking the agents, all the agents, verifying the agents, and it'll show everything. It'll configure the public network. The settings for which are already stored in the file and is going to use the provider physical network. So let's run the script and the magic will be visible on the dashboard. Admin credentials, Neutron to come up, Neutron agent, DHCP agent, verifying that, creating public network created super fast. DHCP namespace, waiting for the bridge to show up. So bridge visible now, you can see. So public network is visible. Now you can see, go and check that network. And if you see, the provider network is configured. This is done. As of now, there is no router. Let's create a public network and create a router also. For that, we have the file config private network .sh. This file is configuring, waiting for the DHCP namespace, then creating self-service network. This is will be the internal network. So it's creating a subnet also, and then DHCP namespaces, configuring that, checking the bridge, and then creating a router, connecting the router. So let me run the script without wasting time so that you can see the results. You can download the script from my GitHub account. So let me show you this one. I'm going to upload this, update it. Last week also updated. So I'm going to fix that and you will find all the files here. So let's see the status. Perfect. This is done. So you can see that a router is created and public network is created, private network is created, and the router is also created. You can see the router also. Let me show back. It will be available under admin section. If I log in with a normal user, I will be able to show you the details where the router will be successfully visible. Even the topology will be visible. See here. And this is what we have. This is a provider network, public network, this is a self-service network, and this is the router to which both these private and public networks are connected. And you can see the graph also where my machines are visible. And these are my network, private and public network. So everything is done super fast. Now let's launch an instance. The script for the same we have here. Let me show you the script. This script is to launch an instance. If you see here, it is checking the IP tables, ensuring that IP forwarding is enabled, and a NAT post routing ENP0S9 masquerade. This is all security rule configured, and finally masquerading is true, and then checking that instance, private instance. So private public key pair, checking all the services, create the required key if it is not there, verify all the agents, verify the Nova services, verify Neutron services, verify subnet. So this is going to be complete automated instance launch. So let me just execute this script. So this will start running on host, network connection to compute node, checking whether it is reachable or not. So it is going to launch it on compute host, but it is reachable. So all the agents services are ready. All agents are ready. Now flavor, we have that flavor already. This is the key is already available. Configuring rules, security group rules to allow connectivity, and then checking the flavors, checking available networks, security group, DNS names. Let's watch the logs in the meanwhile. I'm on the compute and the Nova. So let me check tail-f Nova compute.log. So I started from here, so it's launching the instance right now. This was the instance launch right now, deleting the instance if there is any other instance. And now you can see that parallelly what is going on here. So waiting for the instance to come out of the build state, instance is already active, waiting for DHCP discover. Let's see. So instance is active, you can see that it's running. So DHCP discover is successful, waiting for DHCP success. Yes, it is successful. Waiting for metadata access, waiting for login prompt. So it is testing the instance directly right from here. So the instance is successfully, it has received an IP address. Right now you can see one IP address. It will also allocate one floating IP address. We'll see that as well. So let's see. Yeah, you see here. So obtaining VNC session URLs. This is the VNC session. So I can directly access this URL. It will take me to the instance page. Let me open this URL. This will open the instance directly. The VNC URL for my instance. Then this is a floating IP address, associating floating IP address, and this is a floating IP address for the instance. And you can see that if I refresh my page here, you will see the instance has received the floating IP address as well. Perfect. So thus we have successfully launched an instance from our OpenStack. That's all for this entire demonstration of setting up and launching and working with the instances, object storage, Neutron, networking, block storage, Cinder, all these services. Thank you so much for watching. Take care. Bye bye.